Very warm welcome, and it's the last lecture in this semester, and it is, let's say, we have one of the best people we could get. It's Professor Leonardo Impett. 5 years ago, he made his PhD in Lausanne, and I guess most of you already know the book Painting by Numbers, which I cited a lot. And then he made an unbelievable career, and I can't count all the steps. He ended, oh, no, not ended is a long way. He is actually in Cambridge since so many years, and also, so he's associate professor in Cambridge, and at the same time at the Max Planck Institute for Art History, the Bibliothek Hertziana in Rome. And I guess what he's doing there, he will tell us immediately. But let's talk a bit about my personal interest in him. It is, I never met a person who is so, let's say, enthusiastic if it comes to computer visualization of art. And he is someone who does lots of experiments to better understand what he's doing. So highly reflective, and also at the same time really has his hands on the keyboard. That is a combination I never found, unless some of the people sitting here, in our discipline. So I'm really happy, Leo, that you have that. Just to tell what makes you so enthusiastic. Maybe some of you, or me myself, looked at his GitHub account, and that is interface. So it has an interface that reminds me of my first computer. It's macOS 7, and the tools that we find there are really not on that level, but it looks like that. And that brings me to the point that when I was at your age, I started my studying, I thought now is new age beginning. With the personal computer, everything is possible. That was the time of the first version of Photoshop, and I could have had a very small scanner, only postcards, and I scanned them, and then I was one of the only who had already a hard disk. Most of the working with copy disk, but my computing hard disk was full from one image. But learning this, I found out that the image processing is a very interesting task. The next thing was that, let's say, Apple called this AppleScript. I learned programming because I wanted to automate my work, and it was so easy at that time because it only needed some commands, not many. And every year with a new version, 10 new commands come up. So it was easy for me to follow, much different from today. But the same situation is now with artificial intelligence. We all know that there is something new happening, and we are part of that. And I hope that Leo will be possible to excite the flame to use if it comes to artificial intelligence. So machine visual culture, artificial intelligence, and the history of seeing is this topic, and it goes directly into the core of our discipline.
Thank you so much, Martin. Really, it's a very touching introduction, and I only hope that the level of disappointment will not be so great after such a high bar has been set. I wanted to talk, I suppose, a little bit about a thing I've been thinking about for a while, which is the relationship between, if you like, computational approaches in art history and visual culture on the one hand, often using artificial intelligence, often using computer vision, and on the other hand, these kind of what is now beginning to be called critical AI studies, whether that's a good name or not, I'm not sure, which is all about somehow the cultural study of the AI systems themselves. And I've been doing a little bit of both of these things, or trying to do a little bit of both of these things now for a while. I mean, since 2015, really. And in a way, I started as an engineer, as a machine learning engineer and in computer vision, and I was interested in the kind of cultural positioning of AI before I was applying it to cultural history, actually. I won't bore you with the long backstory, but I was working on automatic image aesthetics for Microsoft in Cairo. And I thought this is an absurd task. So ranking images of how pretty they are from 1 to 10. I have a slide on it later, I'll show you. Anyway, for a while I've been thinking about exactly how these two things might start to work together, might start to speak to each other in a more meaningful way, so that instead of having this kind of split personality, this double existence, if you like, we might try and think of the ways in which they overlap. And I always go back to two references. Unfortunately, they're two references from people who are already completely in the canon, Eurocentric, etc., of late 20th century art history. One is Michael Baxendale, who on his book in Shadows in the Enlightenment in the early 1990s was thinking very hard about computer vision, not just as a tool for search engines or something like that, but really as a kind of conceptual scaffolding. And the other is this paper from T.J. Clark, which is published in 2008, but actually given in 2006. So it's a year before the first iPhone. And he asked what the role of art history might be. Reset my timer so I don't talk for 2 hours. In what he called the age of image machines. So his point is that today, screens and cameras, these are our image machines. They're everywhere. They're in our pockets, they're in our offices, they are behind me and in front of me. People who may be watching this video online live or even later on will be watching it through an image machine with a camera probably looking back at them and so on. And I've written this text on such an image machine. So the question of what these machines see and what we see in and through them becomes extremely important. I don't have to tell you that computer vision, sometimes we call machine vision, which is more or less a slightly vague term that we use to describe algorithms that process visual information in a more or less intelligent way. And of course, the boundaries of intelligence are ever shifting. They've been really the driving force behind the most recent explosion in artificial intelligence technologies. So even though now we might think of ChatGPT and so on as basically linguistic, the huge explosion, to simplify, around 2012, let's say, was really first from vision technologies. And in fact, many of the big early chatbots by people like Yann LeCun in 2016 and so on were copying vision models and trying to adapt those vision architectures for language. Anyway, as soon as we consider the question of bias in vision, which we were just talking about, human or machine, I would like to propose that we start to think, we realize, I think, that the category itself of bias quickly becomes too narrow or at least under-ambitious. In natural language processing, in chatbots, we often associate it somehow with the convictions and assumptions that the imaginary electronic author of the AI-generated text might have. So lots of projects ask opinions to the chatbot and see what the chatbot thinks about things, except, as my PhD student Alessandro Trevisan says, the chatbot is anyway always working within a simulation of a kind of Wittgensteinian language game, right? So if you tell the chatbot, speak like the grandma from Big Red Riding Hood or whatever, then that's the character that will inhabit somehow. But even compared to that, culturally specific visual perception is always more insidious. It always has something slightly more subcutaneous about it. There's no stated opinion, right? There's something behind the scenes in how it's working. But situating I would say, the cultural vision of AI rather than the bias of visual AI, situating the cultural vision of AI requires us to consider the visual culture of the millions or even billions of training images, of example images from which these AI models learn to see, right? These training data sets. Now, the point I'm going to try and make today is that thankfully, in the last decade or two, we've seen the emergence of a set of practices, of discourses, of technical methods, of ways of thinking, precisely for studying the visual culture of millions of images. And that's what we call digital art history. So what I'm going to try and do today is to ask whether and how these emergent practices of digital art history as well as, of course, being useful to understand historical visual culture in all sorts of contexts, might also help us to understand the visual culture of these training data sets, and therefore, if you like, of AI models today. Now, the ideological opacity, obfuscation, if you like, of AI systems, the so-called black box problem, this sometimes has to do with a very purposeful obfuscation, as in, for instance, the invisibility of labor. In many situations, we see continuously the playing out of the myth of the mechanical Turk in Silicon Valley, right? Sometimes it's done in a more or less hidden way, let's say a clip which takes free labor, which is donated somehow by people writing alt text for accessibility reasons, that repackages it as something we can sell. Sometimes it's done in a much more explicit and shameless way, as in this company, this British company, which folded just a few months ago, which was selling an AI which turned out to be 700 engineers in India. So the people who are thinking that the AI is writing code for them, in fact, are just participating in a kind of platformized outsourcing of the old type. But the opacity, I would argue, is not only on this level. It also speaks to the necessary complexity of the algorithms themselves. So computer vision was for decades the prime example of what was called Morawicz's paradox. Morawicz worked more or less on something like self-driving cars. He went from NASA rovers to going to Carnegie Mellon, where basically he made the lab that then Uber bought, very controversially. They bought an entire building, entire lab from the university. Anyway, Morawicz's paradox is a phenomenon in AI research where apparently intellectual tasks, and of course this is highly gendered and so on, such as playing chess, are relatively easy to automate. And so-called simpler cognitive tasks, such as navigating a room, or we might say ironing or cleaning up a house, or, there's also a gendered question there, are far more resistant to automation. They turn out to be much more difficult. And if we feed raw pixel values into a spreadsheet, let's say, they appear on the surface actually to be relatively meaningless. It's very difficult to say anything more than just how bright and what color the average pixel is. And some of the genius of Manowicz's earlier work in the late 2000s is to accept that and to start from that as the starting point, let's say, as the axiom, to say everything is pixels and let's really look at how pixels are distributed. Highly sophisticated algorithms are required to go from pixel values to even the most basic form of image recognition or understanding. And this was true even in pre-machine learning models. The rule-based models were extremely baroque and sophisticated and Byzantine. Although, of course, computer scientists are never quite clear, quite explicit in what they mean by understanding or recognizing an image, even though they're terms that fly about a lot. And it's this group of systems that we call computer vision, more or less. And research into computer vision has therefore long served as the motivational problem, if you like, for the so-called connectionist approach to AI, self-organizing neural networks, pattern recognition, and so on, which basically in the last 10 years has become synonymous with artificial intelligence. But until recently, the majority of tasks that computer vision had been expected to automate appeared, and I underline and put in bold appeared, to be relatively objective. So for instance, automatic vehicle registration plate, what Americans call license plates recognition, was first developed in the 1970s. And we might be interested in studying the cultural bias of these systems. A system developed in the UK, for instance, might miss the umlaut in plates from Göttingen, might not be able to read Arabic plates or Cyrillic plates. But interestingly, Cyrillic plates actually only use the letters that are in common with Latin. So anyway. But it's precisely the clear definition of success and failure, right? You either have identified the number plate correctly, transcribed it, if you like, correctly or not, that makes it straightforward to devise or conceptualize experiments that quantify or identify these kinds of cultural biases. And although it's, of course, far more politically contested, facial recognition behaves in this limited but important sense in precisely the same way. The public debate around the ethics of facial recognition, which has started to lead to all sorts of political pressure and even legislation, I think in Germany and in the United States especially, emerges in large part from several high-profile cases of misdetected faces and wrongful arrests, and from the well-documented racial bias in the accuracy of these systems. And again, it's a bias in the accuracy of these systems, and therefore being able to measure the accuracy is important. This is an especially high-profile early case, the wrongful arrest of Robert Julian Borchek Williams, an African-American based near Detroit, which the New York Times at the time claimed to be, I quote, the first known account of an American being wrongfully arrested based on a flawed match from a facial recognition algorithm, end quote. So again, it's misdetection and bias are synonymous. And at the moment, at present, public use of face recognition has been banned in several parts of the US, partially banned in the EU with some exceptions for law enforcement, and a number of several, of high-profile NGOs like Amnesty have supported these bans. So the characterization of bias is built upon what I might call something like the epistemic clarity of the notion of misdetection, and therefore the notion of accuracy in these sorts of systems. And a classifier which never makes mistakes, so the logic goes, would also be without bias. I haven't written this down, so I had to wake up at 5 a.m. to get my flight this morning, so I will fill you with all sorts of excursuses that are slightly delirious, but there is a fascinating paper published by some mathematicians at Cornell, whose surnames I wish I could remember, but it's called Inherent Trade-offs in the Fair Determination of Risk Scores. And they propose 3 more or less reasonable measurements of fairness in an automatic classifier between 2 populations with unequal positive rates, let's say. So easy thing would say arresting men, arresting women, something like that, right, in this super simplified schemata. And what they show is that these 3 definitions of fairness, each of which appears mathematically quite reasonable, are in contradiction, except in the case where the classifier never makes mistakes. And so as soon as you have errors in the system, not only do you admit the possibility for bias, but you're actually always biased. At least, you satisfy one of the conditions, you have to relax the other, and so on. So with the success of these deep neural networks, deep convolutional neural networks in the early 2010s, computer vision suddenly seemed able to detect new kinds of objects in photographs. Datasets such as ImageNet, Pascal-Bock, and Microsoft COCO, computer vision systems trained on thousands or more often millions of images, which were manually sorted in some sort of pre-established taxonomy, usually a flat taxonomy, learned to recognize these objects in unseen images, in new images, even apparently in new visual contexts. Now, I'd like to point out here that object recognition is an extremely challenging task. I hope the comparison is not too TED Talky, but we went to the moon 4 decades before we could do recognizing a car or an apple in a photograph or something like that. It's really, I'm not suggesting we spent the same number of resources, but we spent a lot of resources. It's really a difficult task. In 2019, a team from Meta, what then was Facebook AI Research in Amsterdam, found that common object recognition systems, including their own, tend to perform better on images of household objects from the global north, open large footnote on problematic nature of these terms, but anyway, than those from the global south. And they suggested that, for instance, when attempting to detect tubes of toothpaste, the systems were implicitly also looking for the kinds of tiled bathroom walls that they might have seen in their Western training data, and not images like the one on the top. Right, so broadly speaking, these 3 are, again, apologies for the clear oversimplification here, but these 3 are described as being global south and are misdetected. These 3 are global north and are correctly detected. If you go into the data, it's also more complicated and more interesting. China, for instance, is extremely normally well detected, but also the data set is itself not an exactly representative sample of residents, so it gets complicated. Anyway, here too, this ability to characterize errors, or more precisely to agree on a definition of what an error might be within a particular task, clearly top 3 error, bottom 3 correct, has been the basis for many of the ways in which we have started to talk about bias in computer vision systems and in AI more widely. Now, this line of reasoning has several important consequences, which I would like to call into question. The first is that because bias is to be found essentially in the explicit errors of a computational image classifier, this limits our view of bias to systems which make, if you like, disprovable predictions, systems which can make mistakes, or rather tasks for which the notion of a mistake is relatively uncontroversial. And as you probably all know, but also as we'll see in the next couple of slides, this is not a restriction which is easy to map on to contemporary AI systems. But secondly, and perhaps less obviously, the solution to this kind of bias, think about precisely this kind of bias, insufficient data from the Global South, is also conceptually straightforward, right? You just add to the training data many, many more examples from underrepresented categories. And this way of thinking about bias leads, I think, too quickly to a kind of extractivist position, right? A kind of data extractivism. The case of this algorithm, the Facebook image recognition algorithm, might well be taken as simply a kind of commercial call to add millions and millions of photographs of household objects taken in the Global South, and then it would simply be a profit calculation. Bias, then, I think, is an insufficiently expansive term for the sort of situated perception that we're dealing with. And in truth, something like Facebook's study hinted at something far deeper with wider consequences for how we understand artificial intelligence. Maybe I don't need to tell this room it, but it's this, that all perception, and perhaps vision most of all, is always historically, socially, culturally, bodily, politically, etc., contingent. And this is no less true for machine visual perception than for our own. Only, I would argue, the stakes in the case of a single computer vision algorithm, which might be operating on half the phones in the world, or a third of the CCTV cameras in the world, or Google Images, perhaps greater than the stakes for any individual human observer. In the case of the 1,000 categories of ImageNet 1K, for instance, even a system which performed equally well on images of the Global South would be bound to the taxonomy of possible categories. Now, these are largely either biological species or industrially manufactured consumer goods. So we have things like laptop, truck, Polaroid camera, and even iPad and Model T. So at least for the many instances of networks trained in some way on ImageNet, and there are still many networks trained on ImageNet that do things like perceptual metric, perceptual distance metric, essentially calculating the error rate of other more recent neural networks, including things like Stable Diffusion, right? All of these networks that are trained in some way on ImageNet have a fundamentally, I would argue, Fordist or post-Fordist understanding of images, right? They think that images are made up of industrially manufactured consumer goods, which you can kind of move around and which are in some way have some sort of important seriality. Now, I'm not saying that's from an engineering point of view, I'm not saying that's a bad working assumption for how to interpret smartphone photographs in the modern world. But it's a different idea of what an image might be than, say, Leon Battista Alberti and the Historia or something like this. Now, a lot of excellent critical work has been done on the taxonomy of computer vision training data sets. But in the last couple of years, we've seen two shifts in the implicit, I think, epistemology of computer vision systems, which again complicates this understanding of algorithmic data. Algorithmic bias, rather. In other words, starting from the taxonomy to uncover the bias. Firstly, a shift away from strictly taxonomic training data. In other words, we no longer have explicit categories, we just have images floating around with very vague and often kind of multimodal annotations attached. And secondly, that's what I was hinting at before, away from solving or posing problems or tasks which have even the pretense, as false as it was, even the pretense of objectivity. Computer vision research now attempts to automate tasks which seem to sit quite explicitly in the realm of subjective experience. And in fact, this is not even such an old, this is not even such a recent example, but I think it has become more and more common. Automatic visual aesthetic algorithms, for instance, try to estimate on a scale of 1 to 10 how pretty an image or a photograph will appear to the average viewer. Now, you might think that this is an impossible kind of replication of the most individual human subjective experience? No, it's automatable to an extremely high degree of accuracy. In fact, we can go into what this means, but it's automatable to a kind of superhuman degree of accuracy. The computer is better at predicting the average human response than we are. And again, computer science's understanding of the term accuracy here is sort of unsettled, right, in this shift from something where it seems to be relatively agreed to actually what we're doing is some kind of automatic visual sociology, trying to replicate the average judgment of a particular set of people, perhaps best understood as a predictor of social psychology than of aesthetics. And I've argued elsewhere, I have a little kind of piece about this in the Photographers Gallery journal called Computation and Beauty. I've argued that this has something to do with the stylistic predictability of the photographers and of the labelers in the training data, the largest group of whom are, it turns out, middle-aged male amateur photographers from the United States. So they like a particular kind of image. They don't like people, they like perfectly monochrome images, they like HDR scenes and so on. And won't have a long excursus, but again, this is a wonderful work from the Russian-American conceptual artists Komer and Melamid, the Most Wanted painting. They did something in the end quite similar. They paid a market research firm to ask people what they liked in their art in various different countries, and then they made the most and least wanted paintings for these different countries. And so you see that actually we have stylistically something not so far away from that, and a kind of logic which is also not so far away from that. Okay. But I think the clearest and, in a sense, most relevant to the digital humanities example of this post-taxonomic and post-objective computer vision system is multimodality, right? Multimodal networks which associate pictures with sentences or, let's say, digital image files with strings of letters. And systems like OpenAI's CLIP are able, therefore, to estimate the similarity between any text string, such as a chair in the shape of an avocado, and any image. And that's all they do. They give you a similarity score between the image and the description. And what this allows, of course, is for image generators to be led by these image similarity calculators. And that's essentially how things like Stable Diffusion work. By the way, Stable Diffusion, since version 2, is also fine-tuned on image aesthetics network. So it actually has all of these kinds of extremely subjective things inside. Now, as I've argued elsewhere with Fabian Offert, AI thus completely overturns these epistemic foundations on which the discussion of bias had been based, as there's clearly no right or wrong arrangement of pixels here that corresponds to the text $100 or the text an armchair in the shape of an avocado. There are obviously more or less successful solutions, but in truth, the image generating system might choose from a huge family of possible images, each with their own cultural associations and nuances, and none quite free of bias, if you like, or of cultural positionality. There is no computational view from nowhere. If there is no computational view from nowhere, where then is computer vision's somewhere? I would say Northern California, something like that, is too simple an answer. The most widely used open source image generation model, and therefore the model we know the most about, is Stable Diffusion, of course, which is trained on the gargantuan Lion 5B dataset, which is named for its 5 billion images. Right? In truth, the number is closer to 6. And then fine-tuned, of course, with this image aesthetics output. For-profit systems tend to have more systems in place compared to Stable Diffusion for reducing the apparent bias of the output. But this word bias has then changed completely its meaning compared to our previous discussion. They tend to operate not in terms of the logic of the model itself, but in terms of the interface. For instance, OpenAI's DALL-E had a number of concerns raised around the racial and gender stereotyping that it produced from its output, much of which we might expect comes from the stereotyping in CLIP, because that's where this linguistic association emerges. And their solution was to add keywords to the user prompt, including woman, Africa, Black, Asian, and female. This is an image produced by the prompt, a sign that spells, and then nothing else. And what's happened is that OpenAI's user interface has injected a keyword trying to compensate for the bias of the underlying AI system, which we can more or less say is probably the bias of CLIP, a little bit maybe also in diffusion, but mostly in CLIP. And because these models have kind of by accident also learned to write, we see this kind of characteristic messy text on top. In fact, after this was discovered, they turned that off, and now it's even impossible to directly write a prompt into DALL-E. So what you do is you communicate with a chatbot which writes your prompt for you. And that chatbot which writes your prompt for you is then instructed, because then again, on the linguistic level, it becomes all simply about what opinions you have, what you describe things as, and so on, so on, so on. As a result of what I suspect is a similar system, Google last year apologized after its new Gemini image generator seemed to add physiognomic diversity, let's say, in any historical context, and the media referred to this as the Black Nazi incident. So I'm sure you can imagine what sort of images were coming out. Okay, so I've gone too slowly now, but uncovering these visual ideologies behind these complex computer vision algorithms entails, amongst other things, a deep exploration of these images that they learn from, right? Their training data sets. How can we begin to study the implicit visual culture distributed through something like Lion 6B, right? Computer vision's enormous training data set. Well, over the past decade, we've seen a rich development of practices and discourses around dataset critique, which try to tackle this question. And what's interesting about them is that they've often emerged from artists rather than from within the academy. And this, for instance, was a project by Gabriel Pereira and Bruno Moreschi, two artists from Brazil. And they sent me a postcard, basically, in early 2021, so during COVID. They were experimenting with new forms of engaging with large AI training data sets. And what they did is they actually printed out different images from different data sets as postcards, sent them to a number of people during the pandemic, who they would then go on to interview a few months later. So the idea is you would kind of live with this postcard in your wallet or in your living room, and then you would talk about it at length. You would sort of slow read this image. And on the back was the text, one image, I won't try and pronounce the Portuguese, but one image of 1,590,611 images. So really this idea of seriality somehow. And I think Gabriel Pereira and Bruno Moreschi managed to convince me of something that many critical AI scholars have been sort of hinting at, but have never quite committed to, which is a special sort of continuity between the photographic archive and the training data set of AI. And in doing so, they drew on the work of previous artists working to highlight, to surface, to expose, to materialize the sort of raw data of computer vision models. This is Trevor Paglin, whose work is well known, but I think still very exciting. In fact, his early work in computer vision, even before neural networks, is also very exciting. This installation, which was in London in 2019, is called From Apple to Anomaly. It has about 30,000 printed images. Here at the front, we see the category hunk. And this is Nicolas Malève, who is now, I think, based at Aarhus. His work exhibiting ImageNet, which I hope will automatically play. Yeah, there we are. Yeah. So this was at the Photographers Gallery in London and circled around all 14 million images of ImageNet, 14, so 14 million images of ImageNet over the period of about 2 months. So it gives each image less than a tenth of a second, then pauses for a bit. Others, again, have used computer vision to look through its own training data sets, if you like, looking back on itself, or looking at new material. This is the ImageNet Roulette face recognition app made, again, by Trevor Paglin with, this time, Kate Crawford, a well-known critical AI scholar for an exhibition at the Fondazione Prada in 2019 again. And it used a model that only looked at these problematic, often misogynistic, racist, offensive categories within ImageNet, and only trained on these, and generated much public interest. In fact, led to the removal of about 500,000 images from the data set. And then we have a whole category of artwork that basically revolves around the search engine. So Adam Harvey's Exposing.ai, there's Have I Been Trained, which Heat of Style has engaged with, and so on and so on. There's also been, and I'll skip through this part, otherwise we won't get to the interesting bits, but there's also been serious engagement with something like dataset critique from the technical community. So we've seen the emergence of so-called data cards and model cards. These are kind of semi-standard, let's say, biographies of datasets or of models that, especially industrial open source models, are now often accompanied by. So together, these form, broadly speaking, two tendencies in dataset critique. One group of approaches turns its attention to the dataset's sort of ontology, which in computer science terms means its taxonomy, its structured set of categories. And this necessarily provides only a fragmentary glimpse into the dataset's visual culture, focusing on what the dataset is depicting or what it claims to depict, and not how. So it traces, if you like, the form rather than the content of the training data. And the second group attempts, if you like, a little bit like Exhibiting ImageNet or like Apple to Anomaly, to delve into a specific subset of images, and it promises a kind of hermeneutics of a fragment of the dataset. This is also the approach promised, if you like, by Pereira and Moresky, right? Sending out one or two images from the dataset as postcards. The obvious challenge then in this form of critique becomes one of selection. Which images do we choose and what are we looking for within them? We might attempt, I think, to reframe this question by reminding ourselves of the stakes of the discussion. Why are we interested in this in the first place? Well, we're interested in the biases in the culturally and historically situated modes of vision, and thus, if you like, in the visual ethics and politics of computer vision systems. We are, in other words, attempting to reconstruct a particular way of seeing from a dispersed, distributed, heterogeneous archive of visual evidence. Now, that last task, reconstructing a way of seeing from a dispersed, distributed archive of visual evidence, this sounds a lot like the foundational challenge of art history. There's a famous quote by Wolflin in the Grundbegriffe. He says, I won't try to recite the original German here, but he says, seeing as such has its own history, and uncovering these optical strata has to be considered the most elementary task of art history. This is right at the start of the Grundbegriffe. And this elementary task of Wolflin has been re-theorized and reframed into a dozen other forms since. For Michael Baxendale, the so-called period eye, John Berger and ways of seeing, what Walter Benjamin called modes of human sense perception, Vygotsky called the history of artistic perception, Vygotsky, the Russian developmental psychologist. Christian Metz, the film theorist, calls the scopic regime, etc., etc., etc. And I myself have been involved in a research network called Ways of Machine Seeing, which clearly tried to play with this Berger approach and kind of transplant it into computer vision. Not only has art history long been interested in the history of vision, but also in developing a practice for reconstructing a kind of social history of perception, also through historical artifacts, by which I mean, yes, pictures, but also, as in the case of Jonathan Crary's work or Svetlana Alper's work, optical machinery. And I don't see the distinction between that and what we're trying to do here as so great. What I'm proposing then is to abandon what I think are the tired and maybe even depoliticized conceptual categories of AI ethics, words like fairness, like accountability, like transparency, and instead try to dig a little deeper into the culturally situated perception of computer vision, into what we might call its immanent ideology of vision. Now, this requires an investigation clearly into the visual culture of training data sets, which penetrates beyond questions of what is depicted, but rather takes this as the starting point for their symbolic and ideological values. In other words, after this kind of dataset critique of this kind, we need something like dataset iconology. Now, the definition of iconology is notoriously slippery. We won't get into that too much, but we have to think a little bit not only about the content, if you like, but about the way in which this takes shape. And this gives us a second problem. I showed you Nicolas Malevey. His work is extremely interesting as an artist, also as a theorist. He has a wonderful paper with Katrina Sluis on the immanent theory of photography and computer vision. His work at the Photographers Gallery in London 2019 took about 2 months, we said, to cycle very rapidly through ImageNet's 14 million images. Now, Lion 5B would take about 70 years at the same pace. And of course, the datasets keep increasing and increasing. Nicholas Merzoff, the photographic historian, has long cited the analogous problem for photographic historians, that more photographs are taken every 2 minutes in the United States today, who knows when that statistic was calculated and how, but you get the idea, than in the entire 19th century. And the entire 19th century would also already be too broad for one professorship, let's say. So how can you possibly be a specialist in contemporary photographic culture? Even if we accept this basic resonance between the task of art history and that of dataset critique, the cultural analysis of a large and somewhat heterogeneous image corpus, then the inhuman scale of contemporary training datasets constrains, I think, our methodological options. We cannot hope to uncover the visual culture of a neural network by simply becoming connoisseurs of the 6 billion images in Lion. By the time we did that, we would either be dead or they would start using a different data set. What we need instead is, if you like, an iconological practice for reading across millions or even billions of images. An art history of the data set, in other words, which is precisely what digital art history, what the digital humanities have been attempting to build for some years. The relationship here, though, is reflexive in that digital art history itself often uses computer vision to arrange the objects of its analysis. So method and object of study become interestingly but also dangerously entangled. If we're going to use computer vision to study training data sets, are we not going to be limited to studying phenomena that are, so to speak, already inside the visual logic of the neural network, right? This is my fear. Here we might try to think through the convergence between the phototech, the art historical photo archive, and the training data set in the other direction. When we look at an art historical archive through a computer vision algorithm, we learn something not only about the archive and the objects therein, but also about the algorithm itself. In digital art history, we are, in other words, studying two visual corpora through each other. We're studying the art historical collection and the visual training data set, one through the other. And if, as in the most exciting current computer science research in fairness and bias, we simply turn computer vision back on itself, for instance, by automatically classifying, say, the gender bias in Lion, then we risk instead assessing computer vision only on its own terms, collapsing, I think, this fruitful tension. In other words, we shouldn't simply take clip and plug Lion into clip and see what it thinks about itself. Instead, we must try to invert it, seeing the training data set, if not through an algorithm trained necessarily on an art historical collection, then at least with an attentiveness to modes of reading that run against the taxonomies of training data sets. Now, this all starts to sound rather abstract, a little bit too abstract to be useful. So I'll try and illustrate it with a practical example, which I added a little bit later. I don't have a slide for. But my first experiment in digital art history with my supervisor, Franco Moretti, was on the subject of gesture. And we had attempted to operationalize, to turn into measurement, R.B. Warburg's theory of the pathos formula, a sort of contagious gestural formula for the expression of pathos. Now, we established a sort of algorithm for the pathos formula, one which we applied on Warburg's own image collection on the Builder Atlas, which I'll say something about at the end of the talk. At first, this was done manually, but eventually computer vision got a little better, we adapted it a little better, and so on, and we managed to do it also automatically, to study the articulation of bodies in images automatically. Now, by taking this, so to speak, as an art historical algorithm, study of gesture, we might then use it to read the gestural iconography of the reference data sets of computer vision, of Lion, of Coco, of ImageNet, etc. It would be more exciting now if I had actually done that and I could show it to you, but just an illustration of how, by not immediately starting from the categories of the computer vision systems themselves, by not immediately starting simply by say, binary gender detection or something like that, we can start to establish, without making our own foundation models, some kind of practices of reading that are really practices of digital art history. And then, even if it's based on post-detection systems, which are, of course, from Google or whatever, then it becomes valuable in any case to invert them and to start really to look at the iconology of these training data sets. Now, it's impossible to imagine sort of reading features over image data sets today without thinking in some way through the work of Lev Manovich over the last couple of decades. Manovich has often worked through what he has called direct visualization, which can be thought of, I'm sure you're all familiar with it, but just to summarize, as a kind of plot in which data points are themselves replaced by the images that they stand for, the images that they represent. And this method itself draws upon the works of media artists like Brendan Dawes' Cinema Redux. This is, Manovich's own admission that this is the inspiration, which, for instance, chains together film stills taken every second into a kind of feature-length film strip. And again, this is not a million miles away from the sort of extraction we do for some kind of digital humanities project about film, right? Extract some clips and then start to work with them as an image data set. Scale, interestingly, is a recurrent protagonist in Manovich's work. He wrote in a 2015 paper, which I'm pretty sure, yes, it's in the International Journal for Digital Art History, the first issue of this International Journal for Digital Art History, which they were running out of Spain. He wrote this paper called Data Science and Digital Art History, and he presents a number of methodological approaches for dealing with 1 million manga images, 1 million artworks of non-professional artists, and 13 million Instagram images, which is almost more or less the size of ImageNet, right? So again, this concern with scale, even the round number of the million, there's some kind of cultural attachment to the question of scale. And when others have developed what we might call Manovichian visualizations of data sets, they've often done so through an interest in scale. So this is Cyril Diagne and Simon Dury. This is their curator table for Google Arts and Culture, the Paris workshop, and it shows 6 million images from the Google Arts and Culture collection, which is actually not the whole Google Arts and Culture collection, but in any case, a subset. Anyway, I was trying to think about the after ripples of Manovich's work and how it relates to scale, and I started thinking that the most surprising echoes of this digital humanities approaches, if you like, the most surprising ripples that the digital humanities have produced are already found far beyond digital art history or digital visual culture or anything like that. Possibly without knowing it, computer scientists are already effectively borrowing something like Manovich's techniques, or at least independently developing analogous ones in a sort of convergent evolution. This is Google's TensorBoard. It's a visualization tool for training neural networks, which is a central part of the popular TensorFlow deep learning library, platform, whatever you want to call it. And it includes this direct visualization of images in an embedding space, which again, might not look out of place in a digital humanities journal if the images, instead of being from NIST, were from some other data set. And again, the gap between digital art history and what we might call the analysis of computer vision systems, because this is a diagnostic tool for computer vision research, is far smaller than I think we have tended to assume. But this is my favorite example. This is from a paper by OpenAI scholars working on so-called structural phenomena in early stage visual processing within neural networks. And they produced, again, something that approaches a kind of cultural analysis of an image corpus. This is, by the way, from a website called distill.pub, which is unfortunately no longer being updated, but which contains many excellent articles on the internal workings of neural networks by computer scientists. So in this case, we have, if you like, a subsequent evolution where the images do not come directly from a training data set, rather they're synthetic images to show the maximum activations of particular neurons. Now, this is an exciting way of probing a neural network, since its visual perception is influenced not only by its training data set, but also by its architecture, right? So actually studying the network's perception of synthetic images is, I think, an interesting approach. And these are quite literally what the German filmmaker Harun Farocki called operational images, images which, in Trevor Paglen's formulation of Farocki's concept, rather than simply representing things in the world, do things in the world. Okay, I mean, that maybe is too expansive a definition, but these are images that are intended to be operations for the next stage of computational processing rather than for human eyes. The boundary between these pictures and training data sets is itself, by the way, blurred by the common use now of synthetic images as training data. And so this kind of iconology of AI, if it is ever to emerge, will have to deal with image expanses of both real and synthetic images, which appear at every stage of a neural network. And I include here these kind of strange interstitial images, which are very far away from what we are used to reading. Now, this is my own 2D clip project, which I made together with Fabian Offert, which you can freely access on your own computers. The URL is down at the bottom right. And it attempts to play on this resonance by showing a direct visualization embedding of any image data set. You can pre-select one or you can upload your own in the same tool. And it's a tool which is really about investigating clip. And the preloaded examples, and I'll show you just quickly here, consist of both, if I can do this, we are, both art historical data sets, the Fitzwilliam Museum, the University Museum in Cambridge, along with some wallpapers for the VA, and training data sets of computer vision, ImageNet and Lion. Of course, not all of ImageNet and not all of Lion. I'll just show you a little bit of how this works, just so you get a feel of this kind of, if you like, two-way relationship between studying the image corpus and studying the network itself. I'm going to do something very banal here. I'm going to type modern art and medieval art, or modern art and Renaissance art, maybe. Right, now, again, what this is going to do is it's going to use these clip similarities as simply axes to rearrange the images. And the Fitzwilliam Museum does not really have much of what we might call, at least in the UK context, modern art. It has some 20th century glass stuff, but not very much. But what's important to note here is that, of course, what we're seeing is Clip's view of the images and not of any kind of catalogue entry, right? Just the images that are representing the objects in the museum. And when we do this, hopefully, okay, we have some kind of blob here. We have to bear in mind that in order for things not to overlap, the blob has been widened somewhat. But I just want to show you some sanity checks here. So these are things that are closest to modern art. Fine. There isn't really any modern art we said in the collection, but something like that. These are the things that are closest to Renaissance art. This starts to make a lot more sense. Idea, of course, is very, let's say, chronologically liberal, the idea of a Renaissance, but as is also the case for much of the discourse in English in any case. And here on the top right, what we have is an image that it considers to be both very much modern art and very much Renaissance art. And it's this image here, which is an image of a frame produced as part of a restoration intervention. Okay, so this is a kind of toy example, but what we do in a previous paper with Fabian is to start playing with terms which mean almost the same thing. So here we have Renaissance art and early modern art. And then what we can do is we can look at the correlation between these two terms. We can see a little bit of, if these things were really synonymous, we would see a straight line. And by looking at the noise in the line, we can start to extract things. We have a much more interesting example, which would take too long to go through the kind of historiography of, but naked and nude, right? These are two words which are distinguished in English and not distinguished in most other European languages. It's a distinction created by art collectors in the 18th century, and it's a long historiographical debate. The phrase "the male gaze" comes out of a discussion around precisely this linguistic distinction, and you can see again this almost straight line which has a little bit of nuance, and then you can start to really think about the ideology of clip and the perspective of clip. Let's say ideology sounds too strong. I mean it in a very wide sense, and you can think about the contents of the data set at the same time. Okay, Now, I remain pretty committed to, the potential of these multimodal image features. This is, again, ImageNet. This is ImageNet 1K, which is what most neural networks are trained on, and simply one image from each category. So we have here only 1,000 images. And again, we get some idea of the sorts of things that are in ImageNet. Very, let's say, clean photos with a composition where we normally have one industrially manufactured object in the center, or in the case of the animal categories, animal vegetable categories, one clearly visible organism in the center. And if I just open Lion instead, you'll see that the iconography is very, very, very different. Much, much messier, in a way, much more interesting. Anyway, I remain more or less committed to the potential of these multimodal image features, but they face exactly the same basic challenge as the image maps that I was discussing previously. In other words, the scale has completely slipped away from us. Now, this is taking a while to load, and it's going to load 5,000 images from Lion. And that is, a small ant crawling on the computer of the 6 billion images that the networks are actually learning from. We can reasonably explore a map of maybe tens of thousands of images through computational interface, as in Pixplot and things like that. We can render a few million, as in the curator table at Google. There's 6 million. That's technically possible, but we actually start to interact with it completely differently. We treat it like a satellite view on Google Earth. We zoom in and out into a few particularly interesting corners and then out again. And we actually over-rely at that point on the kind of topographic organization of the algorithm itself at a large scale, which has been computed for us for our understanding of the data set as a whole. In other words, even if we could load 6 billion images onto one web page, we would, ironically enough, have to effectively place our trust in the arrangement of images by a computer vision algorithm. Now, I realized that I have already spoken for about 50 minutes. I have 3 more pages, if you like, of conclusion, which are a little bit more hopeful. And if you like, I can keep going. I'll just zoom in so you have something more interesting to look at. Zoom in to see some of just how weird the Lion stuff is. I mean, a lot of the things are semi-synthetic. I don't know if you've seen these websites where you buy a poster and there's some kind of CGI generated living room, and then the poster is itself kind of semi-automatically put in, and so have all of these kind of, many levels of, let's say, Baudrillardian relationships to indexicality. It all gets much more interesting in Lion. But again, we're looking at a tiny, tiny fragment, and we can kind of pretend that from this fragment, because it's a random sample, we can understand certain things. I mean, there's a lot of book covers, there are a lot of slides. Can't really make a clear claim as to exactly what's going on. So W.J.T. Mitchell, who's the sort of great advocate of Bildwissenschaft in the Anglosphere, has attempted to trace the intellectual antecedents of Lev Manovich's work and of this sort of digital humanities work. And Mitchell's conclusions are very interesting. He sees echoes of the Musée Imaginaire of André Malraux. That's his famous photo of Malraux in his living room with a double piano, which, by the way, Nicolas Malève, who made the very, very quick video we saw before, had already connected to AI training data sets. And Malraux, for instance, makes some interesting comments in the Musée Imaginaire on the amnesia of scale in photography, such that, I quote, works of art lose their relative proportion, a miniature bulks as large as a full-scale picture. But the central precursor of Manovich and this form of, let's say, cultural analytics for Mitchell is, in fact, R.B. Warburg and his unfinished Builder Atlas, this set of roughly 1,000 images assembled over something like 60 panels, depends what version you take, in the late 1920s. These are some photographs arranged actually after Warburg's death, so we don't know exactly how much they've been interfered with, but there was a very famous reconstruction of them in ZKM about 10 years ago. Mitchell is by no means the first to emphasize the resonance between Warburg and the digital humanities. In the years since my own work, which tried to point to that, something like that, Amanda Dupre's, for instance, echoes Griselda Pollock in declaring Warburg a, quote, thinking machine for digital art history. In other words, a way to think through what we might do in digital art history, with the Builder Atlas as a kind of prototype for computational methods. Naja Lefebvre-Grundtmann, who I think is in Denmark, reads instead the digitization of the Builder Atlas as a kind of cautionary case, right, where we lose something of its original organic, let's say, rhizomatic plurality. She says, or she writes, I quote, automated pattern recognition across large quantity of images is irreconcilable with Warburg's comparative juxtaposition of images, end quote. What's interesting about Mitchell's comments is not necessarily the novelty of this comparison, but he's interested in the nature of spaces, including Manovich's computational image maps, in which the images are displayed en masse. What's the nature of the Builder Atlas as a space? And here I think the comparisons become a bit more fruitful. Warburg is often lauded for reaching beyond so-called high art, studying, as he phrased it, not only the flowers, but the subterranean roots of visual culture. And of course, the source material is highly eclectic and might as well be a training data set. I should have chosen better panels, but in the Builder Atlas we find not only coins and stamps, but newspaper photographs of zeppelins, adverts, and so forth. In an important early lecture on Palazzo Schifanoia, a famous lecture, Warburg called for, I quote, an extension of the methodological borders of our study of art in both material and spatial terms, and to see all registers of visual culture as, quote, equivalent documents of expression. So again, there's something very Warburgian in this project to look into something like Lion as a document of expression of contemporary visual culture, as well as an engine for future visual culture. And Hito Steil's poor images and so on resonate with that as well. But the connection to critical AI, I would claim, actually run far deeper than a simple concern with visual culture beyond art. For instance, Warburg's key concept of the Nachleben, for Didi Huberman, the central concept. We're not dealing here with images that survive because of some sort of historical coincidence or nostalgia, motifs that are resuscitated. The Nachleben is a kind of spectral renewal. Again, in Didi Huberman's words, ghostly and symptomatic. Now, how better to describe the training images which are occasionally regurgitated, half remembered by glitching neural networks, or even recurring figures which seem never to have existed in the first place. Less visually striking, but nonetheless important, is the wider and subtler Nachleben of training data sets themselves. We spoke about how, for instance, ImageNet is practically finished as a serious data set for new foundation models, but is still used in networks which measure the performance of models trained on other data sets. In the unfinished introduction to the Builder Atlas, Warburg talks about uncovering the relationship between a highly distributed, interconnected form of image memory, something like an inherited mass of expressions, and the historical psychology of expression. Kurt Foster, an important Warburg scholar, writes that Warburg understood the meme as emerging from, I quote, a sea of forgetting into an archipelago of data, end quote. So the Builder Atlas in this lens is a kind of experimental apparatus for building upon a vast image expanse in order to reconstruct historically situated modes of vision, of imaging. The basic challenge of critical computer vision today is to reconstruct these inherited mass of impressions of training data. But I want to be a little bit careful here. My intention, just to close, is not, as it's too easy, to claim a false equivalence between the Builder Atlas and the project of dataset critique. Most of the Builder Atlas's 1,000-ish images are, after all, images from high art, from classical or European early modernity. And Warburg's own writing, and I think thinking, is often so contradictory and ambiguous and laconic that the meaning of the Warburgian approach is still highly contested, and perhaps it's really not worth even directly speaking about. But I am suggesting that as digital art history asserts its usefulness for dataset critique, and thus for something like AI studies more generally, it must face up to this problem of scale in a new way, precisely in the way that Warburg had to. There's, of course, this famous joke in a story by Borges, right, about a map so detailed that it could not be made smaller than the size of the empire. And I think much of our current work in digital art history relies on just that, on simulating a space large enough to map out every image in the corpus that we are working with. And that basic assumption is now untenable. The scale of modern training data sets, with each data point represented by an ever smaller image and eventually a single pixel, our atlases would effectively collapse back into regular scatter plots, right? Direct visualization collapses back into the old form of points with axes. In confronting the vast scale of contemporary training data sets, then we have to abandon this kind of panoptic ambition, unless someone has a better idea. Itself is maybe an uncomfortable echo of the project of the sort of Universal Museum and so on, and instead navigate these image corpora through something like these partial interdependent perspectives of the panels of the Builder Atlas. An iconology of training data sets might therefore proceed from this assemblage of highly detailed views, each embracing the fragmentary and the situated. I just want to finish. Now I really finish. I've read the end of my text. I read the last thing I wanted to say, but finish by showing you maybe one of these detailed views, not of a training data set, but of a network itself. This is a heat map also produced by CLIP, and which you can also visit in the browser. I can put the URL up later or send it, whatever. And what we're seeing here is a map of Paris, of course, which has been colored by the similarity between the Street View, the Google Street View image at that point, and the text that we have in the top left. And so, having written graffiti street art, when I click on a very, very red point, I hope to be sent to somewhere where the image from Street View has some street art in and so on. I could do the same thing for gardens. And this would be CLIP's idea of where it looks like there are gardens in Paris. And I click again on one of the red maps, and I hope, here we are, that we have probably the Jardin de Luxembourg or something like that. And now, just as a closing act, what happens when we ask instead the heat map of a photo of Paris? This really is this kind of psychogeography of the neural network, which I'm trying to get towards. Again, this is a very, very partial perspective. This does not map out CLIP's opinions about everything. This does not map out the totality of the associations of Paris in Lyon or anything like that. But what it does do is it allows us to look a little bit closely at what sorts of images CLIP associates with Parisianness, and which instead it thinks have nothing to do with Paris. Like this. And of course, you know, the fact that the images are clearly all images of Paris, I think allows you to turn the network back on itself in, if you like, an analogous way to how we did it in the art historical image collection. Anyway, with that, I've already spoken too long. So thank you so much for your attention and for your time. And maybe we can talk a little bit in the discussion.
Yeah, thank you very much, Leo. So it was more than one lecture. Starting with bias and the difficult definition that we use, going through the whole problem of how computer vision works, has worked, and I really like the history background of it, and coming back to the most interesting part for me, is there a possibility to write an iconography or even an iconology of AI data sets, and how shall we do this? And before I start my comments, I will ask the audience, I guess we have to move on.
So thank you for your presentation. I really like your work because I read before, and also your tests you clip. I was wondering if you have any idea of how to deal with your query, because in Clip's paper they say that the result can change a lot if you specify what you're looking for. So an image of something, a photo of something, and how can that maybe influence the reproducibility of results? Because this is something that I'm facing sometimes when I'm doing some queries.
Yeah, it's super interesting, and the more, I mean, by now Clip, I'm kind of surprised that it's still a model that is used in a way. It's of course it's super. It's actually very powerful for the size of the model. It's such a small model that the websites, they load it in your own browser. There's no server for those websites. It's running in your Chrome. And so I'm astonished by the complexity of Clip given its size, actually. But the first thing, I know I'm taking a long route around, but the first problem with reproducibility is also that actually state-of-the-art vision language models, of course, no longer simply calculate a similarity. You might still do this for guiding diffusion models, but actually you might produce your images directly with image tokens or something like that, as the new Sora does. Probably, we don't know. And these vision language models, something like uploading a picture onto ChatGPT, then the reproducibility is even more problematic. It's about the linguistic context. It's about which other images it's seen before. It's about what it remembers about you, and so on, as well as the natural aleatory nature of these networks, and so on. So the reproducibility problem it's really tough, actually. But another thing was about the specific example that you used in addressing Clip, which is, do we describe that this is an image of the thing, or do we describe that this is the thing? And I think there you actually get at the basic, if you like, I hate to say philosophical because it sounds needlessly pretentious, but the basic rupture in the theory of the image within computer vision. Basically, you have one group of people who assert the continuity between pictures and vision, and I would put David Ma and the people that follow him in that category, and one group of people that think very carefully about the difference between pictures and vision, and I would put James Gibson in that category. And both are psychologists, somehow theorists that have influenced computer vision very, very greatly, both even working around the same time, even though one is much older than the other. Now this rupture manifests itself in the simulation problem. So the main video synthesis network by OpenAI, Sora, it's the press release, let's say, the technical, what they call a technical paper, they get less and less technical and more like marketing releases. What they call the technical paper, it doesn't say we're going to automate Hollywood. It says video generation models are world simulators. Why is that? Because we can use them to train robots. And Yan LeCun, who is of the opposite opinion, I think I would agree more with him, not on everything, but on this, says, no, that's nonsense. To learn to pick up a hammer and nail a nail into a plank of wood, you don't have to be able to synthesize the look of the hammer precisely, pixel by pixel, the grain of the wood, and so on. Again, that's a kind of restatement of the same problem. You know, are pictures continuous with vision? Are they good examples of vision, or is it a completely kind of separate phenomenological category? And of course, things get complicated. Last thing I'll say, because the answer is now too long, but Gombrich had a very interesting debate with Gibson about this in the 1980s. And Gombrich was actually closer to the kind of tech bro opinion than you might think. And he, in arguing for that, talks about all of the kind of instances where mimesis is somehow a bit more ambiguous and a bit more ambivalent. So false teeth. So are false teeth a picture of teeth, or are they teeth? Anyway, I think get more complicated, of course, if you leave the two-dimensional plane.
One question, please. May I help with one question? So if we start thinking about an iconology of those AR, we go back to Warburg or go back to the 19th century where the same attempt was done with plain pictures. I guess everything was about sorting. To find rules, you need, let's say, categories, and those categories you find by sorting. And the thing was, what Abi Warburg does was find formulas that survived a long time and were not dependent on a certain context. For example, you showed Laocoon, and this motive of struggling with death, we find elsewhere, and with this, a certain way of damnation to death is always expressed through the centuries. So that was what he's looking for, and he thought of finding it in sorting images, and he saw them anew and anew. And I'm very impressed that you do exactly the same with your tool for Clip, sorting and sorting and sorting with different categories and see, fits it now or does it fit? And so you're nearer to Warburg than you think, and near to the art historical tradition of starting a new iconography. So that was my impression. And what I wanted to ask is, the result of those approach was to find rules that are necessary to put every other image into this context. Let's say the slide archives of every art historical institute at the time were constructed to have everything sorted somewhere. And that was needed to have our brain sorted. So if you look for icon class, for example, that is the Marburg way of looking at images. And not the way that the Hertziana does, for example. So it doesn't work with Hertziana and stuff. So what I want to ask after this discussion, telling you my impression, is to what task is following finding rules of AI data sets, finding ways that everything could be sorted without bias, coming back to your first point, or is it to have just an insight into that, to, let's say, remodel something that art historians got their impression of how the pictorial world was structured by having a slide archive. And if we dealing with these data sets and look closer to these data sets, we get a better idea and a better way of handling these data because we get certain insights. So what is the aim of your idea?
That's a fascinating and provocative thought, and I think you're hinting at the fact that our fear in all of this is always to repeat formalism somehow, and to repeat a particular kind of.
I'm not against formalism, as long as it stays there. We don't go back and say with forms we could characterize content.
And I mean, one of I have okay, so of course there are situations in which something that we might describe as formalism is more or less appropriate. Poetics is a classic one where it's extremely appropriate, and I have a colleague in Cambridge, Ryan Heuser, who looks at AI-generated poetry and at the weird over-determination of poetic form by AI-generated poetry. In other words, it sticks to, say, iambic pentameter, whatever you're asking for, even more than the canonical examples. It's even closer to the kind of ideal type, in Weberian terms, if you like, than any actual instance. It's a kind of, I don't know, a kind of prototype for the thing that you're asking for. And my gut feeling is that sometimes some of these extremely biased images, or some of these images which are seen as the examples of bias, which again I think is a wrong term, are part of this kind of very outwardly transparent ideological commitment of these images is, I think, their didactic function. Mm-hmm. So one interesting thing, you just about see it here. Okay, it's associated a little bit like in saints' attributes. You see the wheel and you know it's St. Catherine, something like this. Mm-hmm. It associates all sorts of attributes with people which it cannot possibly have poked up from a training data set because they are the wrong attributes. Lawyers do not use these hammers are called gavels. Yeah. They're not used by lawyers. They're used by judges. Okay, you could say judges are a kind of lawyer, but that's a...
No,
yeah. And anyway, they're basically never used. They're used only on TV judges in the US or something like that. Stethoscopes are very, very uncommon for nurses. Now, you asked whether the aim is to develop a less biased alternative. I think that's a very tricky direction to start on. Of course, we would like some of these systems to be less explicitly racist and so on. Yes, but to really say that there's something that there can be such a thing as an unbiased image is, I think, not sustainable. And even when I say ideology, someone came up to me to talk a couple of weeks ago and said, yeah, why do you think it's ideological? I mean, surely it's just representing what's in the data and that's what's in the world. So I don't mean ideology necessarily always in this negative way, in a kind of extremist way. I mean it has a connection to a system of thinking and being. And I think the didactic nature of these images helps explain, if you like, this relationship between form and content. So they remind me a little bit of the images, around the corner of a primary school where you see the apple and the car and, and something, the alphabet or something like this. And their extreme stereotyping comes also from this extreme didacticism in the, if you like, iconography. Is the solution then to compare just demographically what we see here with what we, the statistics we have about the real world? For a start, we would lose these dynamics. I mean, for instance, very interesting here, the colors and the composition of the nurses, the masks and so on. So we would lose all of that. We could say, okay, well, how many people look male or female? Of course, they're not real people. These are absurd questions. Where do they look like they might come from, if you like, in terms of racial background? We can ask these questions and we can compare that to the real statistics, and then we would say something like, these are realistic nurses. In the UK, it's about 90% women. This is actually much better. The original one was all old men for lawyers, but most lawyers in the UK are now women. The model tends to associate it with men. Does that mean the lawyer image is more biased because it corresponds less to the statistics? Already in talking about stereotypes on TV, and especially TV advertising, Stuart Hall in the early 90s said, this is a non-starter. If you try and compare continuously representation to some fixed point, you end up realizing that anyway, that fixed point is never itself uncontested. It's always a moving target. And in any case, you can close that gap and still have something which is, let's say, biased ideologically, especially precisely in the way that things are shown, in how things are shown and not what is being shown. And he says, no, we should do the opposite. We should not be measuring the degree of stereotyping in this statistical way, but opening up the practices of representation itself. I think it's something that we can directly apply to the case of machine learning. Anyway, this is a little, it tells us then on the bias question. Are we trying to get rules? Here, I'm not so sure. We see a lot of digital art history papers which try and take these Wolflin categories, linear, painterly, or whatever. And I think really 3 completely separate, completely independent projects have tried to do this. Max Schick, Eva Chetnich, and Ahmed Al-Gamel from Rutgers. And what can you hope to learn from this? I mean, I'm sure it's excellent work, and I'm sure it's well thought through, but I don't see what you would do with those rules. And I think often even Warburg is much more formalist than people are assuming. He's obsessed by these rules from linguistics, for instance. And yeah, he calls it critical iconology and not just iconology, but it doesn't absolve you of your responsibilities to the material. And I think we have to figure out a different path there. And I'm not quite sure what that path looks like, but I think something like thinking through practices of representation is closer to where I would tend to encourage us to think about, rather than thinking through the creation of a new set of kind of formal rules of thumb for explaining the content of Lion or something.
I suspected that. I thought it can't be done with art historical categories because it's not an art historical sorted material.
Yeah.
So
I mean, imagine getting Lion and putting it into icon class. I mean, yeah.
I expect there's something like, let's say, the class of stereotypes and the class of, let's say, non-European category or something like that. I thought that you would end up in categories that describe more the, let's say, how the corpus is created and which kind of images are there. And that's why I thought starting with explaining what bias should mean and not what it meant.
And you can do that a little bit. I mean, in this case for ImageNet, you can say, look, there are all these kind of clusters of relatively contiguous things. There are things on the land, there are things in the sea. The big difference is essentially these groups, of course, is a bit overlapping, but between man-made objects, which are factory goods or sometimes food, and natural organisms, mostly animals, but sometimes plants. Yeah, you can start to work on that. I think you lose precisely this question of representation. At that point, you go back onto simply thinking about the taxonomy of the data set, which is what we were already doing with ImageNet. And I think we have to do a little bit more.
Yeah, but coming from your new point, it would bring different results than this plain taxonomy that was done. So your approach, the Paris example is very impressive and goes to the Manhattan project of Nefmanovic, where he does not map what he wanted to map, but he shows exactly what the people have in mind and what they like to picture. And that is what, let's say, the expectation, what Paris should look like is more important in this data set than how it really looks like. And that is what might be called stereotype or, let's say, expectation or practice of viewing or whatever. And I thought you have some concepts in mind going in this direction.
Yeah.
Next one. Do we have other questions? It is indeed, it's warm and it's complicated.
It's a hot day.
And so since you were so impressive, it's not easy to find, let's say, major points. We have lots of detailed questions that you don't think we should ask now because they look so, let's say, unimportant compared to your talk. And therefore, I would suggest to leave this place and go to a more open place with good food and some drinking. Where did we go today? Kaigotan, wonderful. Then it's right, you could sit outside, and everyone is invited to come with us, and especially those who feared to ask questions because they're not so well formulated. Even in English, it's more complicated for us. Should join us because Leo is very open and very friendly, and will ask you, will answer you everything that you really want to know. So thanks again.
Thank you so much, Martin.